Good afternoon, fellow foundrymen. This is Sendil Kumar, Secretary from IIF Chennai chapter. And good morning to our speaker, Mr. Georg Grassl from Germany. Before we get started, please put yourself mute so that it is not disturbing the webinar, so that we can give better focus to the speaker. And thanks for your cooperation. And gives me immense pleasure to interact with you, all of you, for yet another webinar, which is jointly organized by IIF Chennai chapter and IIF Southern Region. And first of all, I would like to convey my Diwali wishes to all the members who have joined this festival season. It's a great festival season in India. And I would like to really appreciate, even if busy, this festival session, you are sparing your time to attend this webinar. It shows your commitment for the continuous learning process. And generally, sometimes we blame webinars. No, we are keep on worried about webinars. But I think today it is on the other side. Today we have a speaker from Germany who is addressing due to these technologies, sitting in Germany and addressing us. And this is a very big honor to have Mr. Georg Grassl, Product Manager for Feeder Technology from Chemex, as a speaker today. To formally introduce the all the audience, I request now Vice Chairman Mr. Banagappa sir from IIF SR to welcome the gatherings in formal manner, please.
Thank you, Sanjay sir. Thank you very much. So today we are jointly Southern Region and Chennai chapter, a topic called Optimized Feeding Solutions to improve casting quality and to reduce. The technical presentation will be addressed by Mr. Georg Grassl, who is the product manager for feeder. Yes, sir.
Sir, voice is breaking.
Yeah. Heartily welcome you, sir, for the program.
Yeah, thank you. So, can I start now?
One second, sir. 1 second.
Yeah.
So now I request our council member, Mr. Emma Prasad, introduce the speaker formally to the audience, please. Emma Prasad.
Thank you, Sendil sir.
Yeah.
So it's my immense pleasure to introduce today's speaker, Mr. Georg Grassl. Georg Grassl is a foundry engineer from Chemex, HA Group company, Germany, and has a pivotal role in shaping the success of feeder technology for more than 30 years. He is an architect of innovation responsible for guiding feeders development from inception to launch. He bridges the gap between engineering, design, and businesses, ensuring the feeders meet both customer and business objectives. He is a vital contributor to feeder technology worldwide. He is a visionary leader who navigates complexity, balances competing interests, and adapts to market dynamics of feeder technology. Over to you, sir. Thank you.
Thank you very much, and a warm namaste from my side. And thank you for the opportunity to give this presentation to this audience. So, first of all, yeah, you introduced myself, and it's a great pleasure for me to show this presentation. The title is the Optimized Feeding Solutions to improve casting quality and at the same time reduce the total cost. This is a big need what we have to do, all the foundries all over the world. We have to reduce costs and increase the quality. So, unfortunately, it's not moving now. It was working before. Yeah, here we go. So, on today's agenda, a short introduction, thoughts on foundry technology, what the foundries on feeder technology, what the foundries have to think about today. Then feeder types, There are some common feeder shapes, different feeder shapes all over the world available, and especially the Chemex feeders, insert sleeves, compact sleeves, tail feeder. This is our main product since more than 20 years, and a comparison of the feeding systems. Customized feeding solutions, what we have, and again, 1-2 slides, short conclusion. So first, why do we need to feed the casting? For sure, I think we all of us know why we have to do it, because all metals and all materials increase their volume by heating up, by melting. So, but this means in the opposite, by cooling down, they decrease the volume. This is very nice if we have a raw, a pure material, but if we have some different phases, like we have it in iron, also in steel or other metals, then it's a little bit more tricky. So what you can see here, when we come, it's quite easy in the liquid phase. You see here on the feeder, this is very easy, just sink down. But now, during the solidification area, there it starts to block, and not all the material, liquid metal, can go to the spot where it's needed. And this is where we usually get shrink holes, porosity, such things. So with these two phases, phase 1, the liquid shrinkage, and phase 2, solidification shrinkage, we can support the process with the feeder. In the third phase, the solid shrinkage, this is underneath the solid temperature, when everything is completely solid. Then we have to work with the pattern shop, with the pattern offset. So now, as I said, there are different types of feeders. Let's divide first two big groups. It's a natural feeder. This is by far the oldest one. And then we have bonded feeders. They can be bonded with different materials, or different, for example, with resin, sodium silicate, something like this. We at Chemex and also Gagi HA, we're doing this with a cold box binder. The advantages you will see later. So, but the natural feeders, you have the atmospheric feeder and natural blind feeders. Here you see just two samples. So when we go to the bonded feeder, we can divide in the ram up. It's not possible. This means you usually use open feeders, or you use the blind feeders and add it later on. So both you can use with or without a breaker cup. When we go to the possibility of the ram up possibility, then we have two sections. We have a compact feeder, which is like this. Also, you can use this, the blind feeder. But when they start with the second generation of molding lines, it was possible to ram up, though this is a more efficient shape. And also we have now the tailor feeder. It's a flexible system. You will see later how it works. This you can get, all these types here you can get in exothermic feeder neck and feeder, and also the upper part with non-exothermic. So first, the insert sleeve, we call it insert sleeve. In Germany, we call it EK. This is a parallel conical shaped feeder. So it's an old type. This was started using when they had the first generation of molding lines, automatic molding lines. At this type of molding lines, it was not possible to ram up, place it direct on the pattern before filling up by sand. So the feeders were added later on in the mold. So this type of feeder is suitable for the high pressure molding lines and can be used as insert sleeve, but also now as ram up application. Also, this is useful to place it on the top of a side riser, of a natural side riser, because it gives more power to the feeder and also support the yield, because you can reduce the volume of the natural feeder. These types are available in cold box bonded material and also slurry one. There is another part or another shape of the insert sleeves, which is this one. This one, it's the outer shape exactly like the same before, and the specialty is the inside. We have a much longer Williams bar, and the idea behind is to give more power and to reduce the volume. These feeders also suitable for the high pressure molding line, and the same like the one before, can be used as insert sleeve, but also for ram up application. Also, as the use is useful for the side riser application, and as I said, made for yield improvement. Let me tell you a story what we had in Germany. We had a foundry here, which were using our standard product with the standard William bar. And they used, we call it EK6090W, which had a modulus of 1.7 centimeter and a volume of 178 cubic centimeter. The customer was coming to us and asked us if we can reduce the volume of a feeder, because the idea, the customer had automatic molding line, and the intention was to pour more molds out of the same ladle. So what we made, this was the easiest way. We gave him the same outside shape with the same size in this inner shape. This means then it was called EK6090T. The T stands for turbo. And this was working very nice. We reduced the volume, and we had one side effect because we increased the modulus. Increased from 1.7 centimeter to 1.9 centimeter. This was okay, but customer said, why do I need more modulus and I have to pay for extra material of the feeder material? So we said, okay, let's reduce even more. And we used an EK50 ADT. First number means the diameter, and the second number is the height. So now we have one size smaller to the original one, but with the extra material for the T-bar. And now we have the same modulus like before, the 1.7. And we have even reduced the volume to 105 cubic centimeter. This means from the left one to the right one, we have a saving of, so you haven't heard my story about this part?
Yeah, you can start a
Okay.
little bit early.
Okay, so we start customer at this side, this product with all these data. This is the name. The W stands for the Williams bar, the standard one. And this is a specialty for to improve the yield. So this means we have now with a size smaller compared to this, but the extra Williams bar, we have the same modulus, less volume. So we reduce from this side to this side 7 by 73 cubic centimeter. At the end of the day, customer was happy to do this, and he replaced many of these feeder types to this. And the saving, the total saving per year were nearly 80 tons of liquid metal. So that's quite a big saving. I have customers here in Germany. They do not produce so much the whole year. So this was really a good result for the customer. So I don't know why, but now it's again not working to move. Yeah, now again. Okay. As I said, it's very helpful, or can be very helpful, to place such a sleeve, a standard one or a turbo one, on top of a natural feeder. In this simulation, the picture of the simulation, you can see we have a casting, and we just made this simulation to show what is the advantage. And when you see this one, this is without a sleeve on top. And it's much, in the same time, cooling time, it's very small and even cold hotspot now. Here we have it covered with a sleeve, with an exothermic sleeve, and you see here it's much bigger and is much hotter, much higher temperature, the liquid metal. So this material can still feed, but this one, yeah, it's very tricky now. So this is an advantage even for the customer because he can reduce the size of the feeder. So with the second generation of the automatic molding lines, they were able to place a feeder on the pattern. So the ram up possibility was given, and we developed the compact feeders. We call it a CD type. So these types are suitable for high pressure molding lines. They also, for sure, for ram up, and they can use also for core package application. From the backside, you can place in, and they will seal on this surface. So They are made for yield improvement because compared to the insert sleeves, the volume liquid metal is less. It's smaller for the same modulus. So this is also useful for side riser application and also, as I said, for core packages. So can be used also on top. So also with the second generation of molding lines, and they also increased the compaction pressure, the squeezing pressure. And what we found quite often in the foundries were broken breaker cores, or even not only the breaker cores, in worst case, the complete feeder was broken. So we also discussed with customers and said the most problem were low yield, high fettling costs, scrap rate increase, and limited space on pattern for risers. And we were thinking about what we can do. And one of my former colleagues, he had a good idea. He found a solution, and now Chemex can provide high feeding efficiency with our products, high strength of our products. They will survive all the squeezing. Feeders with a low footprint and a compact design. So the advantages for the foundries are they can use the highest possible pressure, compaction pressure of the molding equipment without damaging the feeder. This gives more freedom to placing a feeder, and also, and this is nowadays even more important because we all know the casting designs are more complex. So now we can mold even more complex casting designs with a high feeding efficiency, and this leads to a better casting yield. And this is a very high and very important advantage. The material what we are using is without fluorine. So this means no fluorine-related defects, like fisheye, for example. When you see slurry products, for example, they have a fluoride content, let me say, in average 2%, 3%. So we have no fluorine in the material. So this is how our solution looks like. We call it the tailor feeder because we have a telescopic movement. When you see number one, we have a high output, volume output up to 50%, means discharging factor of 50%. We have a telescopic movement. This means during squeezing, the upper part will move down, cover the lower part. At the same time, you have no pressure on the lower part, and you have a much better sand compaction underneath the feeder, the upper part. Our lower part of the feeder is always exothermic material, because here, this is the section what we need, what has to be quite long liquid, the material. So we have also added a very nice, and you can maybe see here in this section, a very well-defined breakoff edge, because we like to remove, to knock off easily, and this supports this. So with the material and this, which is very long, hot, because this is, in my opinion, the most important section of a feeder. You can have plenty of liquid material on top. If this is solidified, it will not go through and do the work. But now, at the same time, we like to remove it easily. That's why we have the edge. And number 5, we have all the materials in cold box without fluoride. The cold box process we use because we think this is the best process to reach also the tight tolerances. And this is what we need to get the accuracy to assemble the 2 parts. So this means it's also suitable for the high pressure molding line and also for hand molding. The hand molding, sometimes some chopping foundries or steel foundries which have bigger parts, they do not need an exothermic upper part. So they use an upper part as isolating or with isolating material, and the lower part, it's always, as I said, an exothermic material. So a high discharging factor, as I mentioned, easy knockoff based on this very nice breakoff edge, less fettling cost, also based on number 4. And these feeders are available in oval shape and in round shape. We have the possibility to combine a round upper part with an oval outlet. Or we have both in oval, an oval upper part and an oval outlet. So this is, we choose this according to the application of the customer. Where do we have to place the feeder? What possibilities do we have or the customer have? This is an animation, how it works on an automatic molding line. So it's easy to place based on the inner shape. It will fill up the mold. So please keep an eye here on this section and the same on this. The pin goes through. This is for better venting. And at the same time, you have a much better compaction underneath. This means there is nothing falling down inside the mold during closing the mold. So now starts phase 1, phase 2, solidification discharging up to 50%. For some materials, some application, even more than 50%. So easy knockoff, and you have a very well-defined breaking edge, breaking surface. So this all leads to reduction in riser weight. Here you can see we had a riser, it was a casting, a main plate, material FCD 500, and the casting weight was 105 kg. The riser weight was before 12.7 kg, and by using a tailor feeder, the riser weight was only 3.1 kg. So there was a lot of metal saving, was 9.6 kg per mold, and it was easy to knock off. You can see here the braking surface, so not so much to clean. And this is a big advantage and also a cost saving for the foundry. There's another example, shredder hammer. The material is alloyed steel. The casting weight is 145 kg. And they were using slurry feeders, big slurry feeders. You can see it in the backside. So it was much higher and was a lot of work because what this foundry made, they were using also chromite core, breaker cores, what they made by themselves, and they added the day before. They assembled the breaker core with the slurry feeder. They had to dry everything and then they placed it in the molds. So, and here they had a ready-to-use feeder, a tailor feeder. The weight before they used the tailor feeder was 68.2 kg, and this one was 23.5. So it was also a metal saving of 44.7 kg per casting. An easy knockoff, they were using a pneumatic hammer to remove it. But we made also a trial, even this one you could remove by hand. So, and the fettling was also much easier. Oh, another advantage for cost reduction because case of the fettling. On the left side here, you can see there is a feeder. It's a competitive feeder with a metal lower part, and these molds, it was a very tight area here, and the molds here always cracked. You can see the cracks here. So customer asked for help, and we offered him a tailor feeder. You can see here on this side, and there is no crack. Everything is nice. The customer was very happy with this and is using now this type of feeders. So means less fettling. Here this comes from the spring back effect. And in worst case, it also can crack a little more and some parts are falling inside the mold by closing the mold. And you have sand inclusions and you may have to scrap your part, your casting. So this is safe on this side. Also the good compaction underneath. No mold breakage. Defined breaking edge. And no additional pad underneath. What they had here also. Let's compare different feeder systems. When we see the different feeder systems, we are going the way here like this. We compare and we make the cube test. They all the same sizes, the cubes. They have a weight of 7.4 kg and a modulus of 1.7 centimeter. So this means by calculating the modulus for the feeder, we multiply the 1.7 by 1.2. Means we get a modulus which is required for the feeder of 2.1 centimeter. For a natural riser, you need a very big quantity of liquid metal to feed this casting soundness. So the weight of this feeder will be 6.23 kg. And let's say this is our benchmark, so we say 100%. By using the blind sleeve, exothermic blind sleeve, an insert sleeve, you only need a weight of 1.26 kg, which with the same modulus, this means it's still 20% of the benchmark. So if we add, in case we add a lower part to this sleeve, then we get the tailor feeder. So with the tailor feeder, we even can reduce the volume. So it means now we have a weight of 0.63 kg, which is only 10% out of the benchmark for the same modulus. Also with this, with the fettling cost, when you see the surfaces, this is a high one, lower one, and this is the lowest. So when I say here, this is a theoretical calculation. Yep, this is a theoretical calculation, but to be honest, I can tell you I made trials in 2019 for steel casting, and they had a volume of 21,000 cubic centimeter, the feeder. And I replaced this with a tailor feeder in a certain size. And the tailor feeder had only 2,100 cubic centimeters. So it is really possible to reach these numbers. It's not only theoretical calculation. And we repeat these trials this year, and was exactly the same result. This means a lot of saving for the foundry, because we all know raw material are increasing, and problem what we have now. We also have higher costs. So why can we do this? Here you can see I try to show it with 4 different types. On the left side, we have the sand riser. The sand riser has a discharging factor of 15%. And we have an exothermic open sleeve, which has usually, let me say, round about 30, sometimes a little bit less, discharging factor. It depends always on the material. So an exothermic blind feeder has a discharging factor of 35 roundabout, and the tailor feeder has a discharging factor of 50% and sometimes higher. As I said, always related to the casting and metal grade. So at the same time, you can see here, this is for the, it's shown the solidification time. So here you are quite long, hot, and you not really can say, where is it? Is it in the feeder? Is it in the casting? So there's a big possibility that you get porosity or shrink coats in the casting. Here it is a little bit better. And for sure you need less material. But also in this section, it's not really sure where it will solidify at the end. From this side, from the blind feeder, it moves more from the casting inside the feeder, but still not 100% sure. When you see the tailor feeder, you have still a very, very hot and long time liquid metal here. And here it goes smoothly inside the feeder. This is what we like to have in the foundry. We like to have the feeder at the end solidifying, not somewhere in between, and the metal does not know where exactly we will solidify, and we will create shrink holes. The feeder is the place where we like to have the shrink holes, because we knock him off and remelt him. So, but the casting is good. Company Chemex also developed side feeders. They are made for vertical molding lines or parting lines, like Disamatic, not Disamatch. But the reason why I like to show it here, because the side feeders can be also used on horizontal parting lines. Chopping foundries, but also at automatic molding lines for big volumes. So this is what we call a tailor side feeder, because it's also two parts. It's working like a tailor feeder, but in different orientation, vertical orientation. This is a side insert sleeve, because this you place after molding, or you make it in an extra way. So here we explain a little bit more, or I explain a little bit more, how this can be used on a horizontal parting line. When you see this area here, this crop, on this spot, you will see when you see the complete casting. Unfortunately, it's not allowed to show this. That's why I have only the small section. You can use the standard one, the round ones, for horizontal parting line. But here it does not fit because it's blocked here. It can interfere with this area. What we made, that the customer should place here a small socket, and we placed the feeder on these two spots. Here he is feeding. This is only that it's not bending during squeezing. So, and we have a much bigger volume even beside the feeder, beside the casting, sorry. And this helps. Now we can feed this section underneath the feeder with enough material. This is it's a very big advantage for foundries. And as I said, usually this is developed for vertical parting lines. I have another customer which is also using exactly this part in hand molding. And he was able to reduce the volume of the side feeder and also the knockoff he improved, and it's much easier. He has a smaller braking surface now, and this means less fettling cost, and at the end, less money, or less a lower cost. So, and this is a big advantage for foundries. If you see this casting, we only have the simulation now. We have a lot of feeders on top, but you see here we have to feed in the lower section. What you can't really see here on this cross section, there is a shaped surface, and we can't place a feeder. Otherwise, we have to place it somewhere in here, but we do not come really to the spot where we have to feed. And our suggestion is, in this case, you can go there in the way. We place it in the corporate, which is coming out here, and set it together with the core. So now we are able to feed exactly where we need to feed. We do not need any extra material to create a feeder pass, or we need maybe chills, and we have to take care of the chills. May have different type of chills. We also can reduce these costs, and this is a big advantage for foundries. Let's talk about customized solutions. For example, we developed together a long time ago a pet or some pets. This is only an example. By pouring this setup without this pet, you will get porosity here on the lower sections. Now the customer has only one feeder, and you see how good it works. And you can feed until down here to this heavy sections. Why is it possible? Because this exothermic pad you can place in the mold, you can place on the core. If you have it somewhere else, we'll open the thin sections here as long as needed that we can feed this section. This is working very well. Without this, customer has to use 3 feeders. Now only 1 feeder, 1 pad. Especially if the feeding distance is not sufficient, then this is a good solution. For difficult to access residual solidification areas, a pad will be good and can help. And the pad do not has a shape like this. We can make flat pads, the same like your casting surface. We can have very small one, maybe 2. I have one which is only 3 cubic centimeter big. It's only in a small corner. It's an isolating one. So if additional geometry modification would be necessary, but it's not allowed. Quite often, the end customer is saying, "Yeah, we know this, but you have to do it. We do not allow to add extra material, so you have to remove the material later." And this is inefficient because for high costs of extra casting material. That's all the problem. And if there is insufficient space for placing extra feeders, can also happen. We can also do something like this as a kind of a contour breaker core. This means you have a breaker core which is shaped like your casting. This means you expand dramatically your feeding distance, and maybe you can save some feeders. Yeah, and this is a kind of a conclusion. Here you see what we add, or the added value of our products to your foundry. This is mainly done for automatic molding lines, but it's similar to the one with jobbing foundries, only with hand molding. Because now in general you need less liquid metal. You have a faster cycle time because you can place them easily. You see here the shape inside. When you have a pin, and the pin you can do by yourself. We give the dimension in our catalogs, or if you do not have a catalog, you can get it from us for free, and you can do it by yourself. So it's quite easy to place, means also lower cycle time, but also if you have to pour less liquid metal, it's also in a shorter time. Faster pouring time, you have a higher yield because you need less liquid metal. You are able now to feed the casting where you need to feed. Not like a side riser where you have to be beside the casting and you hopefully get feeded at the spot where you need it. With the tailor feeder, or also with the other feeders, if it's possible on the casting, you can feed where it's necessary. You have less handling based on the small spot. Reduce segregation and also hotspot below the feeder. no fluorine in the material. Also, less deslacking during the remelt of the remaining feeders. It's also speeding up and saving money. Process cost saving. Overall, you are more competitive on the market. And at the end, we come again, less demand of liquid metal. So this is what we can provide to you. And this type of product, especially the telefeeder, is more than 20 years on the market. Started in Germany. This is the reason why some of our namings are still in German. But if we develop new products, they are now also international. But when we started here in Chemex in 1974, nobody was thinking about to go global. And nowadays, we sell these type of feeders in a lot of countries all over Europe, in North America. We are in Asia, Australia. We now working on also start in Africa. So as I said, all over the world, and also in India, we work together with Gargi HA because both of us belonging to the HA group. And yeah, I hope you got a short impression what we can do and what we are able to do, and that we hopefully also add more value to your castings, and that we can work together and improve. So this was my last technical slide. What I like to show you now is just one slide. I like to introduce our app. We have a Chemex app. You will find this on the App Store for Apple and Google Play for Android. The app is for free. You can download it. And there are different types, different areas in the app. You can see animations. You can calculate the modulus. You can choose the right feeder, or it's suggesting you the right feeder for the modulus. You have a kind of catalog there, and you also have different other areas very useful for the daily business. As I said, it's for free download, and I only can offer it to you. Many people say they are happy to have it, especially in the daily business, if they are somewhere in the plant and have a meeting and have to check something. So this was now my last slide. I like to say thank you for your attention. And yeah, I'm open now for questions.
Thank you, sir. Thank you very much. I think exactly you took about 60 minutes. Okay. Gentlemen, if you have any queries, please, you can unmute yourself and ask question, or you can type in the chat also.
And I would like to put a question to Mr. Grassl.
Sir, I request you to introduce yourself first, and then your name and company name, and then raise a question, sir.
Yeah, I'm Jairaj. I'm a member of the foundry, Institute of Indian Foundrymen. Of course, I retired from Steel Authority of India Limited as a general manager. Okay,
sir.
I retired in 2016. Now I'm freelancing something on steel and all that management. Now, just a question to Mr. Grassl. Whatever suggestions he has given, in terms of equipment, is it possible to, have all those equipment done in India or available? How about the availability, indigenous or to be imported? Once you import, then naturally the cost will go up.
So, yeah, what we have now, currently, since last year or 2 years ago now, we import from Germany, but we now start setting up the machines also in India, and we start the production in India soon.
Good.
So
Yeah, then that should be helpful.
Or for long term, the idea is to do all the parts in India. Because as you said, it makes no sense to ship it around the world if we have a possibility to do it right in the country.
Because pollution is a big problem with regard to foundry. Will this, how about the on the pollution side? Will it reduce overall, or how efficient it is in reducing product pollution?
What exactly you mean with pollution? There is some of them, or some of our competitor products. They have a lot of smoke by pouring and something like this. With our product, you don't have this because this is completely covered by sand. And what we recommend, there should be minimum 20 millimeter sand above, and then everything is fine. Also, something we know, I was talking about the fluorine in some products. In Germany, a long time ago, they came up and especially when you have fluorine in disposal material, it will dramatically increase the costs for disposal. So what I know, this came also in 2018 in Japan, and also I think 1 or 2 years ago in some districts in Australia. So more and more countries in the world are trying to reduce the fluorine because it's not good for the environment. And this is a big advantage why we are really saying, okay, we have no fluorine. This is one thing, it's a disposal cost and good for the environment. On the other side, to prevent fluorine-related defects like the fissure, for example.
Right, sir. Thank you. I think others are waiting. Sir, Chandramani, sir. Sir, you are muted. Chandramani, sir, you are muted.
It was a very good lecture, Mr. Grassl. Thank you very much. I have one question. What is the modulus extension factor generally of these sleeves? And normally, what would be the aluminum content in the sleeve?
The cold box bonded tailor feeders we have is from modulus 0.8 up to 8.4, 8.6, sorry. This is what we have now. And if it's bigger, I would say there is slurry a good advantage, or we have the possibility. I'm working on a project where we also have a bigger modulus. But now at this time, I would say for bigger modulus then to think about using slurry feeders.
What would be the aluminum content?
Humidity content. Did I understand correct?
Aluminum.
The humidity we have no. We are not taking any humidity out of the air. Because based on the cold box process, this is a resin. And this kind of resin is not taking out any moisture or humidity out of the air and has no moisture inside. I made when I started in Southeast Asia a few years ago. I had a kind of a moisture meter with me. I even today I always have it with me, and we measured a slurry one, which was the pellet was opened the day before in the foundry, and I had a few left in the warehouse, and we measured this. And at this time, this was in South Java, and we measured this. We had a measurement of 42% moisture content in the slurry sleeve. And we had one feeder with us, which was 2 years, round about 2 years, in the same area, because I have one colleague, he's living there, and he had a sample in his house. And we measured this, and this was showing 0 after 2 years in the same environment. And to show the customer that our moisture meter is working, I measured my skin. So it was really, this is a big advantage of our product.
Yes, sir. So can we move to the next question? Yeah, in the chat, I think I could see some questions. One, Mr. Gauri Shankar from India Pistons from Chennai. He has written, for gravity castings of pistons, where we use reusable riser sleeves, do you have anything to offer?
Not yet.
Okay. The next question is one Mr. B. Dharmaraj from SACL Coimbatore. Nice presentation. Are you giving support for DISA vertical line for sleeves?
Yes, this is, yeah, I did not include it here. But as I mentioned, we have these side feeders. These are specially made for feeders or for feeding on a Disamatic. Okay. So we have also solution there, and we also can support. Yeah.
Yeah. Mr. Sonu Kumar. Yeah, tell me, sir.
I see the question regarding the module expansion factor. We have different ones. And so I think this is regarding what is the AI or AL, aluminum?
Yeah, I think that's what Mr. Rai Chandramurti has asked here. I think he has already spoke to you.
That question, I didn't get the answer for that.
Yeah, same. Okay, yes, asked already. Mr. Sonu Kumar is asking PPT. I think, sir, we'll be hosting this video in the YouTube channel. You can have a look, sir. Gentlemen, anybody else is having any other questions? Yeah, it looks like no questions, sir. I think it's indeed a good presentation. And I think the cost saving factor which you are explaining is mind blowing. I don't know, maybe a real foundryman can appreciate it. Shekhar sir, Kumar sir is there?
Yeah, I'm here. Yes.
Yeah. So now I request our Chennai chapter treasurer, Mr. Kumar, plant head of Sri Venkatadipati Allies, would like to give a formal vote of thanks, sir.
Yes, sir. Very happy. Good afternoon. Today we had a very good and innovative webinar on feeding solutions to improve quality and cost. On behalf of IIF Chennai chapter, I extend sincere thanks with gratitude to Mr. Georg Grassl, product manager, Chemex. We had a very good innovation seminar, the webinar. Yeah, 40% improvement on the gating system or the feeder reduction is very good cost saving project. Very well appreciated your time. Being a weekend, the two in Saturday, you have presented your presentation. Thank you so much, sir. And I thank our Chennai chapter members and other chapter members and also the other regional members. Thank you so much. And I once again thank you all for this attendance. Thank you, one and all.
Thank you, sir. Thank you
Was
very
a great
much.
pleasure.
Thanks for everyone. Thank you. Bye.
So thank you, Sendil sir, Grassl. Thank you, sir.
Thank you, sir. Thank you very much, sir.
Thank you.
Thank you.
Sure.
Thank you.
Thank you.
Have a
all.
nice
Happy
day.
Diwali
Bye.
to you all.